Strange and Charming, a podcast by physicists about life in science. Welcome to a new edition of the podcast Strange and Charming. My name is Robert Harlander. I'm a professor of theoretical particle physics at RWTH Aachen University. And today I'm looking forward to the conversation with Gilberto Tetlalmatzi-Xolocotzi, postdoc at the Institute for Theoretical Physics at University of Siegen and a member of our collaborative research center on particle phenomenology after the Higgs discovery. As usual in our podcast, the physics we are working on shall only play a very minor role in our conversation. It should rather be directly about Gilberto, his personal career, the ups and downs he has gone through on the way to where he is today. But first of all, welcome, Gilberto.
Thanks, Robert.
I practice pronouncing your name. It's a very complicated name, and it suggests that you're not from Europe. It actually suggests that you're from Mexico, and I know that you're from Mexico, so maybe you can tell us something about the beginnings of your career in Mexico.
So I studied my undergrad in Mexico. So this took place in in a university and a research center. So firstly, it was in a place called Puebla, that is 2 hours driving from Mexico City. It's actually quite interesting because there is a famous, at least in Latin America, I think was famous, Volkswagen factory there. And then afterwards, I moved to a research center that is in Mexico City, in a place called Simvestab, that is attached to the second important university in Mexico, is the Polytechnic Institute. Yes.
And somehow, how did you get interested in physics? Do you come from an academic family or?
So not at all. So my mother is a housekeeper. So I think she only did the high school. I think so, probably only the secondary school. I'm not quite sure. But my father went to university. He studied chemistry, but then he was teaching in high school. However, my father used to buy a lot of popular science magazines, and these magazines were circulating at home. They were just around, scattered. And then I was something that triggered my interest were all the pictures of spaceships and dinosaurs and stuff, actually. So then I was interested in biology, then in chemistry. And my interest in physics started in high school. I was in a public high school in Mexico, and public education in general is not that good. So at least it was not that good back then. However, I was lucky, so I could say most of my time in high school was up to some degree. It's a bit strong, but I think it's not an exaggeration. It was a waste of time. But I have good lectures in programming and in mathematics. I was lucky. So actually, my programming foundations come from high school. So I learned C++. And then the second thing was mathematics. So I started getting interested in mathematics. What I liked about mathematics is that it didn't require memorization. Something that I liked about mathematics as well was that you would be able to check if your answer was correct and also if your understanding was correct. So, and it was not ambiguous. It was not like, I don't know, the kind of statements that you need in social sciences. I didn't like social sciences. I couldn't see myself studying law or any of these disciplines where you have to memorize, and sometimes the arguments are ambiguous. So in mathematics, the answer was very well defined. You could check if your answer was correct. Yeah, so, and there were some documentaries on Discovery Channel. So my father could afford to have a cable television, and then the documentaries were quite interesting. There was a lot of stuff about space. So I got interested in astrophysics. That's how things started. And also there were books translated into Spanish. But for instance, there were books by George Gammon, popular science books that were accessible, but they were not expensive also. There was also, I have to say, there was a movie that so Carl Sagan also. There were several books by Carl Sagan. And there was this movie called Contact that Julie Foster was there. This appeared in 1997 after Carl Sagan passed away. And what I liked about this movie was this connection between the earth and the heavens and the earth. So it really got my attention that indeed if a advanced civilization could contact the earth, this could be through the language of mathematics, for instance.
So that movie was sort of a trigger for you also to study math, to study physics?
Yes, because in the movie there is this at the end, the main character travels to a distant galaxy using a wormhole. So then it really triggered my attention the fact that by studying mathematics, you could actually unveil the secrets of the universe. That was like it was really it was like magic. Like you could sit in your desktop, solve equations that describe how the universe works, and you could access to the stars from your desktop. That was a very cultivating idea.
So then you studied physics, okay? I
Yes.
understand that what the motivations are justified, I would say. It's a great movie. You like mathematics. That's, of course, important prerequisites to study physics.
So the way this worked was the following. So in Mexico, as I said, there were two stages, one in Puebla, one in Mexico City. So in Puebla, there was one academic who actually this is a fact. He was somehow I would say the academic grandson of Einstein. So the way this worked was the following. So during the Cold War, there was a Polish academic called Jerzy Plebanski. He was in the group of John Wheeler, actually. But because of World War issues, because of the Cold War issues, he couldn't stay in America, so he moved to Mexico. And Jerzy Plebanski was a collaborator of Leopold Infeld, who was close to Einstein. So then Jerzy Plebanski was the supervisor in Mexico of this academic who actually teach me during my stay in Puebla. And he offered the lectures of general relativity. His line of school was motivating general relativity from the point of view of electromagnetism. So then my interest for field theory started. So Yang-Mills fields started there in the classical sense, let's say. And then in the second part, that is in Mexico City, there were people doing string theory in this place called Simvestab. And there were also people doing particle physics. So then my original idea was actually to do a string theory.
But I mean, your first publications, if I look, was related to Higgs decays, and it was already sort of in this flavor.
My first publication is something about the muon collider on top. It's from that was my first publication. That was in 2009 or so. Yes, that was the first.
That was your PhD, or?
No. It was in the undergrad. You can make a small project, and this small project led to a very simple publication. I mean, there's nothing spectacular there. Then I move abroad, but for the master and the PhD, I move abroad. But yeah.
So even for the master, you moved abroad.
So the undergrad, as I said, was first in Puebla, then in Mexico City, and afterwards, I moved abroad for the master. Yes. I got a scholarship because that's how most of the students in Mexico go abroad. So actually, there are I could say two main places where back then Mexican students used to go to study sciences. It was the US, because it's very close, and the second place is England. And then the way you go to study in England, for instance, is through a scholarship. I mean, my parents will never be able to afford the high fees that you have to pay to study in England. So then I got a scholarship, and but the way it works is you first submit your papers to a university, and you get the acceptance from the university. You can compete for the economical support in Mexico. So then back then I picked Cambridge. And indeed, Cambridge was strong in string theory. So actually, my group theory lectures were given by Michael Green, who was one of the authors of the first superstring revolution.
The scholarship, that was a Mexican scholarship, or?
Yes, so then Mexico paid for the studies, but as first you have to be accepted from the university. So yes,
Sort of, you have to have the right good grades and so on. You apply for the scholarship, and then you can go abroad.
exactly. So first you have to be accepted by the university, and then you have to compete for the money. And in the competition, of course, is better you have something decent to show. You have to prove that you're worth it and the money. So yes, that's how it works.
And so then in Cambridge, you did your master's degree.
Yes, it was 2000. This was 2010 and 2011. Yes.
So and did you have so you had to write a master thesis, or?
No, so the way the Part 3 program works is that you have to take a given number of credits. So you have a lot of freedom. So there are lectures on pure mathematics, applied mathematics. So actually, quantum field theory is considered applied mathematics for them. There's even mathematical finance, quantum information and stuff. And you can go to any lectures you want. And then this is the first term, the second term, the same. And then at the end, you have to pick a set of lectures where you want to be assessed. So then the requirement is you have to fulfill a certain number of credits, and you can replace one of the exams for a small essay. It's not a thesis, it's essay. So basically, there is a list of potential topics you can pick, and it's essentially just reading a paper and summarizing it, or a couple of papers and summarizing some topic.
And so then from there, how did you get to Durham?
So the way this worked was the following. So as I said, so my interest was in string theory, mostly. And what I liked was I didn't wanted something that were completely abstract. So because in string theory, you can go to those, you can get really formal. So what I was from the very beginning interested in is something that could be tested in an experiment. This was 2011, so the LHC started running, and I was having the lectures on supersymmetry. And I remember at the end of the lectures, I used to get close to Ben Alanak and just talk about stuff. And then, based on these conversations, it seemed to me that I was not really reading papers back then, but it seemed to me that supersymmetry was getting in trouble. We started getting in trouble. And the idea I had was that in order to introduce fermions into string theory, you need supersymmetry. It's not afterwards there were all other methods developed, but back then it was supersymmetry. So then, if supersymmetry was starting to get in trouble, also in some sense, superstring theory was getting in trouble. So then I said, probably this is not the way to go. Probably it's better to do something that is, let's say, closer to the energies that the LHC can prove. And talking to some friends, they told me there is this area called B-meson physics that seems to be becoming very important. I guess back then the anomalies started. I'm not sure actually, because this is very early in my career, but they told me this B-physics phenomenology seems to be very promising. So then I said, there is this place in the UK called Durham that has this big group on phenomenology. So then originally my idea was to move to Durham and to work with, there are two people with the same surname, it's the father and the son. There is Valery Kose and Valia Kose. So the father does quantum chromodynamics. The son is well known for doing, indeed, BSM, actually. So then my original idea was to work with the son, doing new physics phenomenology. But when I arrived there, he was busy. He already had a student. So I got the offer from Durham, and then I went to Durham. But then Valia had already a student. And what they told me is there are new people coming as well. So And these new people, these new members of the staff don't have students.
Before we continue there, so you had to apply for a PhD grant or something in Durham, or?
So since I'm not a British student, indeed, so I have to apply for economical support, and I got again into the Mexican competition, and they sponsor also my studies.
So again, sort of the funding came from Mexico.
Yes, yes,
Ah,
because in the UK it's hard to find funding if you are not from the UK. So then there were, as I said, there were three new hires. One of them was Alexander Lenz. The other one was Benjamin Pekjak, and the third one was J.P. Anderson. I talked to the three of them. So J.P. and Benjamin Pekjak, they were more on the QCD side. But what discouraged me, for instance, to pick Ben back then, I think was not a good criteria, but it was that the idea was to program in Fortran. And I said, okay, Fortran is too old. So even in high school, the first thing I took was C++, and I said, Fortran probably is not the way to go. Even if I want to go to the industry, Fortran may not be the best choice. But I think it was a silly argument. But then I went and talked to Alex, and I said, I already have the idea that there was something called B-meson physics, or quark flavor physics. And it was not as glamorous as at the first sight, it was not as glamorous as supersymmetry or even string theory. It was not about extra dimensions, and it had nothing to do with gravity. There were not exotic particles or resonances at first sight, so on. It was just a low energy, the study of bound states of quarks. But when I talked to Alex, there was a line that convinced me, actually. And I told several years afterwards, I told him the line that sold me to flavor physics was the following. So he told me, in B physics, you are always betting to the right horse because you do precision calculations that allow us to find indirect signs of new physics. When you compare them against the experiment and there are important deviations, then this is a hint that there is something else behind. Okay? But even if this doesn't happen, by doing the calculations, you improve the precision of something that can be measured. So in this way, you always win. And this was precisely the line that sold me to flavor physics.
Yeah, I think Alex Lenz is always very good at advertising his physics.
I mean, of course, it was a good choice. As I said at the beginning, he was not so glamorous as all these fancy things that I have studied before. But in retrospect, I think it was a very good choice.
I'm actually surprised, but maybe you did talk about this with Alex Lenz, which programming language you're supposed to use when you work.
Ah, so back then it was Mathematica, actually.
Okay.
That at the beginning also looked that glamorous, but
Yeah. Okay.
you see,
I wouldn't even consider Mathematica a programming language, but
it
anyway.
has its own, right? It has its own because you can actually do programs. You can do routines and stuff. So it has its own. Yes, it has a programming language there. So it's yes,
Okay,
uh,
so that's how you got into B physics.
exactly, yes, indeed.
I remember B physics from a time before you were sort of scientifically born, before you started your scientific career, and it was even more promising, I would say, because back then nothing was known about the or very little was known about the CKM matrix and so on. So people were very, very excited about all of these experiments that were designed for measuring the entries of the CKM matrix. And there was always this will the unitarity triangle close? And it would be such a coincidence if all these experiments which overconstrain the unitarity triangle will actually be compatible with one another. But it turned out to be exactly.
Yes. Unfortunately, the standard model always seems to win, right? Sometimes we are the victims of our own success, I would say.
So then, after your PhD, you had your first postdoc at NICEF, right?
Indeed. So I went with the group of Robert Fleischer. Yes.
In Amsterdam. Mm.
Yeah, exactly. Yes. Amsterdam was a very exciting place to be, I would say. It's very motivating. And something I liked about NICEF was the at least in the case of B-physics, there was a very narrow connection with the experimental group, the LXCB there. So the experimentalists were eager to hear what the theories say, um, and the theories were very eager to talk to them. As I said, at least that was happening with the group of Robert.
And you were there for 3 years, or?
Yes, yes. So indeed, I was there for 3 years, and yes.
And so that was the first time that you were not on Mexican funding.
Yeah, exactly, exactly. That was that was entirely paid by the Netherlands. It was a postdoc paid by the Netherlands. Yes.
So, and then after that, again, somehow your ways crossed with Alex Lenz, because if I see it correctly, then after NICEF you went to Siegen.
Yes, but Alex was not here back then.
Oh yeah,
So
okay.
no. So I met Tobias Huber in Daisy in 2015, and my PhD thesis was very phenomenological. The topic required a lot of phenomenology. So I learned different aspects of physics, mostly on the non-leptonic side. So something that triggered that caught my attention was mathematical formalism to study the non-leptonic decays. So it's QCD factorization. And Tobias calculated some of the amplitudes in QCD factorization up to next to leading order, if I remember correctly. So I already knew some of his papers. Well, so when I met him in Daisy, there were enough conversation topics during dinner.
But he was not at Daisy. You met him
It
for
was a conference. Yes, he was in Siegen. I met him in a conference exactly. And that's how I met Tobias. And when I was applying for the second postdoc in NICEF, so I have 1 year left in NICEF. So Tobias, I see the offer from Siegen, and it was Tobias. I was hiring the group of Tobias. Yes.
I see. Okay. And so for how long have you been to Siegen now?
Since 2019, but I mean the original contract was from 2019 to 2022. It was 3 years.
Okay.
And afterwards, there was a confounded grant between the European Union and SIG, and it was one of these international Marie Curie. So it's not the normal one because this one is also longer. It's co-founded.
Mhm.
So then the idea was to, I mean, I wanted to continue the projects I was doing and so on. So then the idea was to do a coordinated stay with the IJC lab in Orsay in Paris. So my contact there was Sébastien de Cotenon, who is one of the persons. He was one of the main persons in the SIG-MFITER collaboration, for instance.
Mhm, mhm.
Yes. So then that's how things extended.
Okay.
Yes. But no, yeah, indeed. So yes, I have been for some years in Germany. I mean, in particular Siegen. So I have become fond of Siegen through all these years. So it's, I mean, at the beginning, the transition between Amsterdam and Siegen was a bit abrupt.
Mhm.
Siegen is a bit more quiet than Amsterdam. But I mean, as the time passed by, I would say that I really like Siegen. I could say it's an excellent option to do theoretical physics.
So not considering physics, I mean, you've lived in many different places, Mexico, UK, Netherlands, Germany. Could you say that, I mean, if you had to choose from a not physics point of view, but from a sort of a quality of life point of view, where would you go?
I would say it depends when do you ask. I also spent some time in France. If you have asked me when I was a bit younger, I would have say I would have loved to live in Paris. So I have stays there between 2022 and 2024.
But then the older you get, the smaller the place you want to live, or
Once more, it depends. I would say this: the answer to the question you are asking is time dependent. When I was younger, I was pretty much looking forward for a city because these are international places where you can meet lots of people, international people, and so on. There are, let's say, in terms of things to do, there are options. There are concerts and museums and so on. Actually, one of the things I really liked in Amsterdam was that there were, I like classical music. And the Concertgebouw is one of the top places, one of the top places with the, I mean, in terms of acoustics, it's one of the top places in the world.
most of the people that I know that spend some time in Durham or England, they have become fans of the UK also, of like pop culture and stuff like that. Whiskey culture.
Yeah. So yeah, I mean, actually, Durham is a university town, and it's pretty. It has its own charm. Is also very international because of the university. So I have a good time there. I mean, I made good friends there. And one of the hard parts to move or to change place is actually to leave your friends.
Yeah.
That was one of the and Durham was the first time I felt that. So I established close connections with some of my British colleagues, and one of the hardest parts was actually to departure from. I would say not only it was not really that much the place, but the friends I make there. Although eventually everybody moved away. Actually, they moved to other places and so on. So the best place where I have been is time dependent. I would say I really enjoy currently my life in Siegen. So for instance, in terms of physics, the group is quite strong here. That's, I think, is fair to say. And then in terms of living here, the accommodation cost is quite low. You can get something good for a low price. So I am paying about 800 euros rent per month, and I have a 100-meter square apartment. So in Amsterdam, I was paying that for a shoebox. I mean, it was it was not good in terms of size. So then living expenses are not so high. Then the supermarkets and so on, you always find what you need.
I don't know if you ever talked about anything that you do like for leisure. Do you climbing and stuff like that, or?
I like swimming. So I was doing swimming for several years, also because I have a condition with my bones. So my bones have a problem. I have scoliosis, and swimming is very good for the problem. And then I start doing climbing, and there is a bouldering place here in Siegen that actually this place have played an important role in during my stay in Siegen because I have made several friends there. During my stay in Siegen, I have made different postdocs, and sometimes people are a bit harsh to Siegen because of the social life. So I remember coming across international postdocs who were telling me that it was really hard for them to socialize. However, I was lucky. So by going to this place, to this climbing place, I start talking to the locals. I mean, I would say this was not something that happened from one day to the other. But I start making friends, talking to people, and so on. And this actually made my stay in Siegen, or has made my stay in Siegen more pleasant. actually. I would say it have make a huge difference. So it's the climbing place is a friendly place. I can talk to people outside physics and so on. So it's not only the exercise, but also the social aspect. But yeah, so then I do climbing, and when I was in Amsterdam, I was actually doing dancing, and I took dancing classes, and
Ballroom dancing.
no, it says Lindy Hop.
A Lindy Hop. Okay.
Actually, I start from scratch, and then I never saw myself as a dancer. This happened for random reasons. I never expect that I could dance. My mother tried. I mean, I am from Latin America, and Latin Americans have the reputation of being, say, people who likes to dance. But no, I was terrible. I was really, really bad. My mother tried for years, tried to make me dance for years. It didn't work. I just couldn't coordinate my body and so on. But somehow in Amsterdam, things were different. So and I started taking dancing classes. Some friends were doing that, and I followed them. And eventually, this became a very, I would say, an amazing experience. So actually, one of the reasons why I didn't want to move away from the Netherlands was because of dancing. Yeah, I enjoy this a lot. Yes.
Lindy Hop group or Lindy Hop club in Siegen.
So it's funny because Lindy Hop is also strong in Germany, as far as I know. I was unlucky. In Siegen, there is none. I think there's a school, but for different reasons, the time slots didn't work, and afterwards, it just didn't look.
Quite a special kind of dance. It's somehow something between swing and rock and roll somehow, right?
Exactly. So yes, I mean,
And people are, I mean, they dress up in this 50s.
I never did that. I never. That was too much. You don't need to do that. That doesn't necessarily make a difference in your dancing. So, no. But yes, indeed, you can do it. This is actually from the 30s or so.
Mhm.
It comes from the Black community in America.
Let me come to another question I have, namely, I mean, you're from Mexico, and then now you've traveled around the world somehow. How often do you go to Mexico to visit your family, or I assume you still have family there?
So yeah, I mean, so I departed from Mexico City in 2010 because of the master in England. And so that's 2010. So that means that I have been abroad. So that was October 2010. So it's almost 15 years. Okay, so in those 15 years, I have been in Mexico. Let me see. So it's times no more than 5 times actually.
Okay.
So it's yeah. So during my undergrad, I was once. During my first post, so no, sorry, during my PhD, I was once. During my first postdoc, I was once. And actually, I have been there 4 times. In the last 15 years, I have been 4 times there. So I don't go there quite often. So I was afraid actually that by going there, my mother will not recognize me anymore. So yeah, but yes, I don't go there quite often. Let's say that eventually you get quite busy with physics and so on. You don't feel homesick. I don't feel homesick. I mean, actually, when I was in England, let's say in terms of adapting to the place, this took about 2 months because I mean I was just thinking about the lectures and so on. So as your mind is so busy, one of the hardest parts was it. So in England, things get dark very early, and at the beginning this was having a effect on my mood. But as I said, eventually you are busy and thinking about the academic stuff that, at least in my case, I forgot about these factors.
Another question. I don't know many Mexicans in physics. I mean, you have colleagues from high school, from the university, and so on. So, what is the fraction of people that make a career like you? I mean, that cannot be so many, and probably there's not so many of these fellowships to go abroad, to go to Cambridge, and so on. So this is something that's rather rare and special, or?
I'm not sure. I mean, there are not so few people actually studying physics in the undergrad. At least that was the case. Not at the beginning. So when I started my undergrad, most of the people who were studying physics were people who didn't manage to find a place in another career.
Mhm.
So I was one of the few persons there who really wanted to study physics. So even my family questioned my decision. My father was not precisely happy for me picking physics as a career. So the prospects of making money were not clear.
Mhm.
So in some sense, because there are not too many points of reference. So it's more common that people study law, study medicine. So there are too many doctors, I mean, medical doctors, too many lawyers. Now, going abroad, indeed, it was not a first choice for several people. Actually, from my generation, we were only two people who went to the UK.
Okay, maybe as a final question, I always ask people this question. So, your career also now is like 15 years or so, maybe doing active research, maybe a little shorter, but still, typically there's something in your career which you're particularly proud of.
That's I could say that's difficult. What I like about phenomenology is that the exercise in several cases is not entirely academic. It's not just constructing a model that lives only in textbooks or in papers. During my PhD, I work with Michael Spanowski. So Michael does a lot of this collider fino stuff. You have to use high energy software. You do simulations using Monte Carlo, and then you play the role of God. You play the role of the experimentalist because you generate events, you generate the process. Then you write a small program to look for signal, background, and so on. Yeah. So then there are of course theoretical ideas that as a theoretician you can use to your advantage, or you want to test so that you can sell this afterwards to the experimentalist. So then I started working a bit on this collider fino side. There was a lot of fun on doing this kind of physics because there are challenges that you have to overcome.
Okay, I think we're through. The only thing that remains for me to do is to thank you for the exciting conversation. It was a pleasure to do this podcast with you, and I'm sure our listeners got yet another good idea of how different the careers of physicists are. Thank you. All the best for your future career, and see you next time.
See you next time, Robert. Thanks a lot for the interview. It was very nice.
This podcast was funded by the German Research Foundation through the Collaborative Research Center Transregio 257 P cubed H, Particle Physics Phenomenology after the Higgs discovery.